In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel.
Hello everyone, my name is Nathan, otherwise known as Old Man Builds. We have Joe here today and we're talking about cymatics. What's up,
All
Joe?
right. What's going on, Nathan? How is everybody today?
Oh, everybody's good, man. Just another lively day, getting ready for it.
That's it, man. Really good topic for today. A topic that ties in with all the rest, I think, at the most basic and fundamental levels. I'm sure everybody that watches this channel probably knows a thing or two about cymatics already, but generally speaking, what cymatics is it's the acoustic wave effect of that wave function on matter. So all of these wave functions that ultimately create matter in the first place also can come into resonance with it or dissonance with it. And depending on the conditions in which the prima materia of the matter is consolidated and condensing, is quite deterministic on its organization and what it ultimately becomes at the atomic level. I think that sorry, I'm catching up with the comments. So I think that visually it's just a really stunning thing. I think that it's one of those subjects where if you knew nothing about cymatics and didn't even know what it was called and just saw it for what it is, it's just so interesting and beautiful that you could just sit there and be mesmerized by it for like hours without making any more sense of it than that. Yeah.
Let's see if I can't switch the view. No, that didn't work. Sorry. Still trying to... Nope, that's not it. Trying to switch the view to view the thing behind it. Anyway, what I was looking at when we were looking at this stuff, and we're looking at all the frequencies and stuff like we always do for all of our shows, and I kind of noticed something, and it kind of came to me all at once. So we always look at an atom, and they always talk about electrons on the atom and how it's forcing something. And then some people say there's no atoms. So if you don't have atoms, what do you have? You basically have fields. So if you have fields on it, what is the exact shape that you're looking for in that field to replace the atom? Or not replace the atom, but replace the electron in the atom. So when we come across cymatics, what I'm looking at is there's fields that are generated. They generate them without the electron. And then now we can clearly see what it might be if electrons don't exist. Now, there's two sides of each story. Some people say they do. Some people say they don't. I don't know which way I fall on it. I just know what I see, and I always see the pattern, and I don't see any electrons pulling off it. Of course, obviously, we wouldn't be able to see that, but I've never seen it under a microscope. I've never seen it in any physics experiment. I've always heard about it. I just haven't seen it. Maybe I'm looking at the wrong thing, but it's always been interesting to me to try to equivalate if you just have fields, what is it going to look like?
Yeah. I think a good way to visualize that in your head, if that's what you were proposing, wouldn't be all that dissimilar whether there were electrons and subatomic particles or not. I think that it falls on the same category of like one of those like cheap Chinese spinning toys, where you have like the LED lights that light up in sequence and you spin it around, and then depending on their pulse rate and their rate of spin and everything, that it would ultimately trace out basically a holographic pattern, at various points of its face.
Let's take a look real quick, and we'll pull up some images here.
Great.
So if you just had fields, this is what it would look like, right? But then basically when you take frequency and a lot of people may not understand this, but if I divided frequency by 2, say if it was 108 and I divided by 2, I would basically hit 54, and then I'd be able to have the same pattern, but it would be a different number. And I don't think people realize that. So if I saw the shape on the left here in the water, I'd get the shape on the right in a snowflake if it came from the sky. And all I did was change the amount of time that it took to get there, which is changing the frequency. And I'd be able to get both of them.
Yeah, no, I hear what you're saying there. I mean, this picture is fascinating just generally because one thing that immediately catches my eye on it, is not only the snowflakes and how that's directly related to, cymatic propagation and its freezing crystallization pattern, but just if you look at call it a mandala, I suppose, to the left, where it's being compared to, you see these points where what you're referring to is a field line, where they actually spiral into each other. If you hold that in comparison to the snowflakes on the right, you could see that this is a pattern of condensation and voids, where those little loops on the mandala are like toward the center, for instance, would be analogous to where there would be no condensate because of destructive wave interference through that field pattern. And obviously because it's circular in nature, there's an active symmetry here as well, which we all know about snowflakes, but is also omnipresent in terms of mandalas as well, and is omnipresent in cymatics.
So I got a question for you. You said destructive. It could be constructive as well, but would that also mean that you would get one pattern for the original frequency and then you get a secondary pattern overlapping it with the destructive or constructive side of that equation?
Well, right. I mean, right. Is it destructive or constructive at those certain points? I mean, I guess that would be kind of difficult to say depending on the material's resonance and whether it's going to be positively or negatively charged necessarily, because there's going to be a want to condensate with bits of its like. So I mean, I guess following that logic, it would be deconstructive, because where the energy flows is where the condensate would likely be. I think that's sort of what's present in the cymatic diagrams,
Well, I asked because at different levels, say if you're on the ground level and you're looking into water, right? You're at one level and there's going to be an energy pattern that comes out of the vortex at that level. But then when you're in the sky, there's going to be another, it's going to mutate a little bit when it goes to the vortex and it gets to the level of the sky. So we're talking, 25 miles or something like that? Mm-hmm. Difference in how it is. So that's why I was asking about constructive and deconstructive, because basically if you had the same pattern, it's the same pattern up there, but then it overlays with a secondary pattern based on the mutation of the pattern, could it then have a different look? So it looks slightly different coming down because it took on an additional mutation to it.
I mean, yeah, it's quite possible. And I would say that when snow forms low in the atmosphere, it is absolutely and totally different than it is when it forms higher in the atmosphere. When you get that light, fluffy, you could look at a whole entire pile of snow and pick out a single snowflake with your bare eye. Like that's as a result of it being formed at high altitude. Whereas when you have freezing rain, or you have these big heavy wet clumps of snow and stuff like that might form in a lower level of atmosphere under different atmospheric conditions, different temperature conditions, generally speaking, you don't have as coherent and beautifully structured crystalline formation. You know, it's irregular. You know, I've gone as far as seeing snow that's freshly fallen that appears to be shards, you know, when it's thick and wet like that.
Okay. Let's see. A snowflake could be frozen history of the fields that passed through it, possibly. Yeah?
Absolutely. Yeah, water definitely has a memory.
Yes. The pressure is also in the equation. So that brings up another point. So we talk about frequency and how it works. And I find this funny because I don't think anybody really understands it. When you run your Tesla coil up just on your desk, your open air, it's going to run at one frequency. When you take that frequency and put it into the ground itself will slow it down with impedance. So now that frequency will change. It'll still be on the same pattern of that frequency. It just changes the speed, right? So the speed will change, but the amount of energy increases because now you're using an active resistance in order to create the energy field around it, and it builds up in there. So just like heat would build up in your wire, and you can use that to propel more amps once it's released, this kind of works in the same way.
Yeah, it definitely does. Every time I think of resistance, I have a hard time, getting like the image out of my head of just people running down a hallway that just gets narrower and narrower until it gets to like a single door, and it's like, but the thing is that you gotta the same number of people could exit that door no matter how many people are crowding up behind it, but everybody's still damn well pushing for the door. It's that same push for the door that is the mechanism of the heat, through the resistance. And anytime, you have an accumulation of something under pressure pushing, you're going to have outward expansion because it's not trying to take the path of most resistance, so it's going to try to expand in order to, accommodate for that. And that wavelength expansion is an amperage increase, and that's how I generally think about that whole entire idea. And it plays right into, the whole resistance and ground thing. And it also plays right into pulling cold energy, because the inverse being true as well.
I always thought of it like we're making an AC flyback, right? And we wind it, we put it on this little coil, and then we want to run it, but we want to keep it cold. So we take some mineral oil, we put it in a little Tupperware container, and then you go, okay, well, I can run it now, but then every bubble is going to be a hot spot. So every bit that's compressed together like that in that bubble is a hot spot. So if you vacuum it, you take out all those hot spots and it runs cleaner and cooler. But the earth, you can't do that. It's going to have hot spots everywhere because it's basically like Swiss cheese underneath this. So you're going to have pockets where it gets hot and picks up more energy. And then if you end up with a lot of those spots around the same area, it may start to cause a little bit of a reaction and heating that whole area where it's not supposed to be heated.
Yeah, but that's where introduction of just fluid in general is the benefactor of that symptom.
Yeah,
that's what it boils down to, and that's it goes right back to what you guys were talking about last night with putting the probe into mud, dry mud, wet mud, salt brine solution, salt brine mud. It all comes down to filling those pockets. The tighter to the conductor that you could keep the energy flow, or let it expand either way, the less adversity and inconsistency that you're going to get in any sort of flow run.
I think it's going to be interesting in the mud because I can't wait to see if there's, if there's hot spots in it and you can pick it up on a camera or something like that, and then you put the rod down in there and see if it's hollow or not. You know what I mean? Is there a hollow spot there? Is it more solid there? What actually is it? Is there dirt clod in there? You know what I mean? What is it that's making it hotter? I think that's totally amazing. And I have a good feeling that it's just going to be open air inside there in a pocket, because then it'll be able to breathe and pull air in a little bit. And, you know what I mean? It'll just break the water. And then you could get hydrogen in there maybe. Maybe you end up with a different gas inside there. And then that gas may be able to create a thermal pocket where you'll have heat and expansion because of energy. So I just find that whole test to be fascinating.
Yeah, well, if I can make a suggestion on it, if you want to do just dirt, not mud, right? What I would suggest is just dampening the dirt enough that it sticks, just like sticks together, but isn't sopping wet. So it's not enough free liquid to fill in any voids necessarily or anything like that.
Oh,
just enough to keep it to clot, you know. And then when you stick your probe into whatever it is, take your temperature readings to see where you could identify the hot spots, so to speak, mark them at the surface, you know. And then what you can do is freeze the block and then cut it with a sawzall or something, you know, and then that way you could investigate what the internal structure of those particular spots looks like.
That's interesting.
Like a permafrost.
Yeah.
Like
would give you a good idea of the cavity or not and what it created. That's interesting.
Yeah. And especially if you had some layering effects and stuff like that maybe you do inside of like an acrylic bin or something, you know, like if you were to do like a layering effect with you know, quartz, you know, crushed quartz and crushed feldspar materials, and you know, then you just mix that up with some different soils and organics just to see. I mean, realistically, I mean, you're going to be grounding energy into it, but it into itself is sort of like an orgonite type cell, you know, based on the, you know, crystals and then the organic, you know, if it's stacked up like that. Yep.
Interesting test. I'll tell you that. That's for sure.
Yeah, it's very cool.
Let's look at this a little more, because I don't think what people realize when we're talking about winding wire and doing coils, we're looking to create this structure here. We want the fields to come out of it. We want to be able to see exactly where the energy is and what the pattern is. So we know that we're going to get sound out of it. We know we're going to get frequency. We know we're going to get octave out of it. And, you know, we're going to get a lot of different things. We're even going to get fifths, thirds, I mean, things like that, all out of this one pattern based on the wiring design.
Yeah, absolutely. And I think that following exactly how these patterns flow also gives you a good estimate visualization of what the field patterns and the field interferences ultimately look like at, you know, as a shadow of themselves, of course, but you know, like at least the generalized shape of it. I mean, looking at this particular cymatic, which again is directly analogous to any Mandela, really rings true to me about Gerald's dish coil, you know, where it's cupped, you know, and, you know, because it's cupped and it has that extra axis of dimension, so to speak, while still maintaining inner dimension as well, allowing for the the inner coil to be within it. You know, I think that that's the best way of achieving, you know, the patterns that are visualized cymatically, but achieving them at the higher dimensional, you know, the higher dimensional shape of the same.
So I got to go back to this because I'm going to ask you. I brought up mutation earlier when we were talking about the actual snowflakes and stuff, right?
Mm-hmm.
So we look at these coils and they're multi-patterned. So you have maybe 20 layers of one pattern, and it's going in a dimension, which just basically means it rotates in a certain direction. And then you have 180, which means it rotates in the opposite direction. Now you have another pattern that does it. So when I asked about the mutation, I'm also asking, when you get the final frequency pattern, is it layered based on each frequency? And what you see from the top down view would be all the frequencies at once. So you wouldn't necessarily just see the bottom one. You wouldn't just see the second one up. What if it's like a 5 or 6 layer sandwich that you're not looking at from the side where you see the cross sections, but you're looking at from the top down where you see all of it at once? So it's like an overload to your brain, and you can't match up just one pattern when you look at a mandala. You have to match up all of them.
Right. I agree. If you're going with the like equator cut of a torus, let's just say, and we'll keep it simple by saying a torus, and you're looking at it from the top down, that's the most complex visualization of field and wave interference patterns that you're going to possibly see is from that. If you were to cut it the other way and visualize it from the side, then you get those plasma type men effects like you see in the old drawings and stuff, where it's like a guy with his arms up and legs spread, and the head, and that's what you see is that bell shape in the middle, which is much easier to digest and understand the flow pattern under those circumstances than visualizing it from the top down, because of the counter rotation of the 180 degrees out of phase, because that creates an ever changing and whirling interaction of equatorial effects.
Mm-hmm. So you're right to bring that up, and I didn't bring it up because I didn't want to make it overly complex in the beginning. I wanted to build to it. So now that you have, so we got these layers of the actual building of the wire. Now we have the layers of the patterns that are created, right? Now you're going to take into effect what the fields are doing. So we can clearly see from this picture that the center is the exact same signature of a magnet. Anytime you have a toroidal shaped magnet, this is the inside frequency pattern that you're going to get, or field pattern you should get when you have it. Then you got to also look at the outside of this is taking on the field pattern of the outside as well. But once you start introducing the field, now you're going to introduce rotation and vortexes. And the reason I brought up that they're 180 degrees out is because they're a pump. So when you look at something like this, and I want to go a little bigger so you can see it. When one goes, it pumps. Then the other one goes, it pumps. But it still feels like it's doing this. You know what I'm saying? Then it goes, it's pumping the stuff up and down. So what comes out of that? That pump comes out of like a speaker, and it creates the frequency to be able to get these patterns off of it. Mm-hmm. It gets the actual sound patterns off of it. It gets the octaves off of it. It gets all of that all in one, right? But it's also building as it goes up into that vortex. So as it's rotating up like this, then it's going to mutate a little bit and change as it goes to each layer that comes off of it, because your toroidal builds out a layer here, it builds out a layer here, and it builds out a layer here. And as they come in contact with the vortex itself, where they come in contact with it, it's going to change. So we look at the frequency that it lowers or raises as you go higher into the atmosphere. Well, there's not a whole lot of different impedance up there. But as you cut it lower and lower into the ground, there is. So that's where we get the difference in the actual timing of the frequency in the lower Earth. But then it makes you wonder, if the snowflake is created in a still moment of that pattern, how is it so slow? What did we miss? Did it get thicker in viscosity up there? Did it reverse?
I'm sorry to interrupt, but I just had a thought. And while you're talking, would you mind pulling up the snowflake photo again that you have?
Yeah, not a problem.
All right, cool.
There you go. Hold
There,
on. And there it
there
is.
she is. All right. Yeah. Okay.
You want to
So
zoom in on the snowflake?
you can zoom in on the snowflake. So what I found interesting was this, and it ties right into kind of what you were saying. Okay. Um, Now, when you have a coil and you're putting out these fields like the ones that we're seeing, okay, you have to realize that the fields are being built off of the, you know, electromagnetic propagation from the coil itself. So obviously, the coil being toroidal in its own nature, you know, and then the fact that the electromagnetic fields are being produced from this torus with a hollow center point and a hollow exterior, so to speak. Okay, that's significant. And then it ties right into like Sean's ball also, and you'll see why is because of the nature of the propagation and the formation of these crystalline structures. You'll notice some of them, okay, have a hollow middle, like a dot in the middle. Okay, anything with a dot in the middle would have been formed from toroidal fields
Okay.
because of the fact of that it's collapsing in the middle, and that's how you get your center 0 point. That's how you get. That's what that is. Now, when you're looking at something that has a solid in the middle and it's explosive from that, that's the same as a drop of water in a bucket, you know, where the rings concentrically come outward. See, like when you're dealing with a torus and you want to think like hydrodynamically, if you have a cylinder that's open on both sides where you could just drop the cylinder straight into the water, you know, once that cylinder drops through the threshold of the surface tension of the water and it collapses at those points, you know, where the waveforms would ultimately form, you're going to have a peak at the center as opposed to a dip.
Okay.
Yeah, if that makes sense.
Oh, it makes perfect sense.
Yeah. And the cylinder is analogous to a torus. That's why you would have a peak followed by a dip, a drop, and a bubble when you drop a cylinder into the water thermodynamically, as opposed to a drop of water in a bucket propagating outward.
Okay.
Yep.
I want to take a look at these, Joe, because you sent them to me.
Sure.
These right here are cool. So we see these on every single church building, things like that. Any kind of medieval structure like that. They did real good at churches of putting everything like this in there in the stained glass and everything. And they always correlate to a frequency pattern, or like, you know, what we're saying right now is they're telling you a story you didn't even realize they were telling you, aren't they?
Yeah, that's absolutely true. You know, these things have been known for a very long time, but you know, it's all been very occulted. The degree to which they actually knew these things becomes boggling to me, you know, because we only generally think of cymatics in context of, you know, today, where we're able to, you know, create vibration and frequency and sound through speakers and different types of electromagnetic technology that could then be transferred to a membrane surface to create these types of patterns. And in fact, the first studies on it were only done in the 1970s. That's how long it took to realize this self-organizing frequency-based, you know, phenomenon in the modern age. But yet it's been ever present, you know, throughout all of history. And, you know, a lot of the finest places to use these types of geometries in their structures all boil right back down to, you know, the Knights Templar, you know, and Rosslyn Chapel, you know, they had all these types of windows and structures carved right into all of their pillars as well. They even had musical songs in block form encoded into the pillars of their church or cathedral.
Well,
You
they
know,
also show them in vortex form too, so they swirl right up the actual pillar when you
they
go
do.
into there.
Right. In fact, a lot of these structures, if you look at them, think of it as the top down of a pillar that they built too. Um, when the Knights Templar, came under ridicule, they just really rebranded as Freemasons at that point, and the Freemasons were the ones building all the grandest structures, across the entire world, basically. But they've known this stuff for a very, very long time, which really begs the question: not only how did they know, but what were they using it for? Because they knew the significance.
Well, and I'll say this in my own thinking of this, the Coral Castle, when you look at it, did he actually understand the Egyptian secret? Was he making these patterns when he made the sounds and stuff? Because he had a ton of musical equipment in there, and did he use these with energy patterns to match those that are actually formed inside the coral? So when we look at that, I always put it to, if you look at a crystalline form, we see a pattern in it. And every pattern has a different layer that shows the same pattern, but it's then twisted sometimes in order to build the first geometry structure. Did they really understand it just like the Egyptians did when he built this thing? And was he able to resonate this thing and get it to lift with just the harmonics of it?
Yes. Like I don't say things matter of factly all too often, but I'm going to say yes. I mean, we know in today's day and age that acoustic levitation, there's only certain places I could go with this conversation, but vibratory energy is that is the prima materia, is acoustic energy. I feel that acoustic energy is the primary constituent of every other type of energy form that is to follow through its own, more complex interferences and so on. That's how I generally feel about it. I mean, the monks, like there's recent accounts, whether you want to believe it or not, as to them using resonance and acoustic harmonics to have full control over large and heavy stones and objects, to levitate them, to get them into place, and not all too different than some of the stuff that you see in the coils. There's a certain amount of saturation and capacitance that has to occur in order for the effect to take place, which is why it's not instantaneous. It's a buildup. They have to blow a couple of horns. They need to adjust the tone because everything has a slightly different resonant frequency. So you make the adjustments until you start to see the telltale, the shake.
Well, I love the fact that you brought up the horns. Okay, so check this out. Every time I see the monks, two different horns, right? We see those, and they have other things that play as well. But then you always see the bowl. And I don't think people understand this. You take a cup, you rub your finger around the rim when it has water in it, and you get the sound, right? Now, you simply take the same bowl, and it's doing it by exciting the frequency inside of the boulder that they put in there. So now as that goes, they're putting a frequency in there that's actually inside there. So it's bouncing back on itself and creating the pumping action into it, which is actually charging this thing up. We all know that sound is a push, right? So it's easy to move things with sound, but it has to be out of the frequency of the actual earth in order to do it. What I mean by that is it's no longer beholden to gravity at that point in order for that sound to make it move. So they must resonate it. Just like, people on a bridge that are too many and the bridge starts going out of whack. You have horses on a bridge, it makes it go out of whack. That slow hertz frequency that it continues to pulsate at builds the energy inside there. Because you have the bowl, it's now sitting in a chamber. Now it'll rise up from the chamber and you can use the sound to shoot it off.
Yeah, that's exactly right. Well, it's also not ironic that the C knots back in WW Deuce, you
Yeah.
know, they were making their creations in a bell, you know, aka a resonance chamber, you know. It's none of it's very ironic, you know. The ideas have been around for a long time. Yeah, it's crazy stuff. You know, I mean, think about like Hutchinson, you know, like he was using a form of cymatics, you know, to bring things into resonant frequency, you know, and once that resonant frequency and it was achieved, there was a form of material liquidity that was, you know, forgoing in the material. And then by changing that frequency would then distort the internal structure of metal and other types of material because because the resonant frequency was reached, it reached a point of fluid, you know, molecular fluidity.
Yeah, I'm going to look for this one right here, Joe.
Yep. Yeah, that's the notorious one right there.
Yeah, because it tells the whole story, doesn't it? People ask, why did we change? Well, because they wanted to screw this up so we wouldn't figure it out. But I had somebody arguing with me on my site the other day, and it was like, well, you have to understand, because he didn't understand how it screws up the pattern. So 440, that's a junk pattern, just so everybody knows. If you want to look up junk in the dictionary, you'll find that pattern right there.
It's a pattern of dissonance.
Yeah, it's like white noise over top your pattern. So it's that mutation that's bad that you don't want. So it's not an overlap in frequency. It's not natural. So it destroys the frequency. Where you see it on the left, you have what, 432 is what it is, I think? Because I can't see it right here. But that one shows the actual pattern, and it's so much different.
Yeah, so there's these interim frequencies in nature, just generally speaking, where this goes into the esoteric a little bit as far as like male and female, and I'm not talking about like gender, I'm talking about like you know, male and female from, you know, like from the esoteric sense of things, you know, where they say that a female you know, attribute would be like a sine wave, you know, where it's following the same path, you know, it's just simply taking longer and more variation to get there, you know, and because of those variations, it becomes more susceptible to being disrupted, you know, in the sine wave pattern, even though it's a more fluid movement, you know, whereas you have the male pattern, this ties directly again into male, female, and Fibonacci, you know, sequence where you have a square wave, which is more the male attribute of things, where it can go straight from one to the other, you know, with nothing in between, really. You know, the vertical part of the signal is really just the connection between the top and the bottom of the wave sign. You know, other than that, realistically, it's binary. You know, so anytime, you know, you can have certain male, so to speak, frequencies, you know, and patterns that it'll change from one beautiful form to the next, to the next, to the next, like at the turn of a knob, you know, whereas anytime you're dealing with a female energy, sign form, you know, you could be dealing with, you know, a lot more shit patterns like this one. Well, you know, like that's just the nature of the beast.
Let me just describe this pattern in a different way. If we had an AM radio and I turned it into 432, I'd get a perfect signal. If I went to 440, you would go over there listening to rock and roll and end up listening to a Mexican station halfway through your broadcast. This is what this is. It's two different actual stations coming together in one
Mhm.
and causing interference with one another.
Yeah,
Where
it's a state of dissonance.
there you go. So it's easier to understand that way. So when you map out your fields, and Gerald tells me this a lot, right? And he's absolutely right when he says it. Take an AM radio and listen for that fuzz. When you hit the fuzz sound, it's the sound of the two fields interacting. That's the 440. That outlines where your field is in the room. Interesting, right? You have your original pattern, you have your secondary pattern. They come in contact with each other. So in my case, it'd be a Tesla coil field. Then it would be a scalar field. And as soon as they come into contact with each other, that's the border of my field. So now I know where it is based on the junk frequency of 440. Is I can find that white noise that comes in your radio right at that point.
Yeah, it's it's definitely something that societally we've become accustomed to, where if the change was made, halfway through, like, listening to 432 tuning, and then it switched to 440, like when it did, I guess back in the 30s or 40s, whenever they did that, and at that point, maybe then there would be like some kind of audible, or internal difference that you could sense. But, having been born into 440 tuning, it becomes dissonance par for the course, I suppose.
Well, what's also ironic is you get into frequencies of language. And when you get there, there's certain languages that are harmonious. There's certain languages that are not. And some of them sound like white noise. Some of them sound harmonious. And I can tell you that, for example, anytime that I start watching something, since I can't hear very well, only the ones that are very clear come in. And it doesn't matter what language they are, they come in very clear into my ears. The ones that have any fuzz in them whatsoever, or they don't sound right, or they don't harmoniously go together, absolutely just sounds like white noise to me.
Yeah, I can understand that, sure. No, I mean, a lot of it has to do with like inflection and the way that people speak, and that stuff too. But some languages are definitely prone to better enunciation and fluctuation in speech patterns than others, I suppose.
Yeah, it's just interesting. They changed it when they started during the whole Nazi thing. They were looking for stuff, and when they did, they came across every one of these patterns, and you notice that's when they changed it.
C nuts, Nathan. C nuts.
Okay, well, whatever they are, the bad people.
I'm doing you right there.
There you go. So, anyway, basically, what they were looking into, everything that they came across had frequency in it, and in order to hide what's actually going on in what they knew back then, is they just changed the frequency so that it would throw everybody off the path. And if you were, I don't know, one of those people that fell for it and think that 440 is better, I don't know what to tell you. I guess if you would listen to it musically, it would sound better if it was at 432, but it also awakens something inside of you when you get the right frequencies.
Yeah, it does. It's something that I ought to look into, just because my curiosity is kind of piquing a little bit as I'm thinking about it. But when you think about like white noise, and you have multi-frequency wave patterns and so on that are in a constant state of interference with one another, causing the sound. I wonder how that registers cymatically under different conditions as well, because we kind of got a little off track last week, not too far off, but I forgot to mention, I think one of the main things about Preston Nichols, and when he was going through his boring ass seminars and all that shit that he did back in the day, that like basically get a root canal rather than watch. But he was talking about how a lot of the systems were utilizing white noise sources as their native frequencies, and how they would split those white noise sources into different, filters and so on to use it in their system to get the type of outrageous effects that they claimed, and again, those effects, their experimentation was absolutely outrageous. So
Yeah.
I'd
Well,
just be interested to just visualize it, because is it static on a television or is it not? I don't know.
Well, I think honestly, we don't give enough credence to energy patterns and frequency in those energy patterns in our normal lifestyle. And you only notice that when you go out to the middle of the woods and there's nothing out there, and then suddenly your mind is at ease. There's no more tension. There's no more drama going on. Your mind finally corrects itself, and you're able to do things you weren't able to do before. Get a clear thought out. Get to 2 sentences without something else interfering in your brain with it. You don't tend to have an argument with yourself out there. Everything's just kind of nice and clean. That angel and devil on your shoulder are no longer talking to you. It's one mind talking. That's the difference in this. That's why it needs to be understood. We are not in the correct frequencies for our daily life. That's for sure.
Yeah, what you're talking about is, that's so much deeper and profound than anybody wants to give credit to, because, realistically, in like a perfect state of being, which I know I have never been in, and I would suppose that nobody I know has been in either. I could imagine, though, a state of being that is entirely based off of intuition, where like you're able to seamlessly follow what you inherently know, and the path is clear, like, and that's exactly what you're describing. It's all of the conflict and external nonsense and dissonance and interference that puts the angel and the devil on your shoulder, and you got to flick the one guy off to pat the other one. It's sort of how it goes. And the closer to out of that dissonance that you get, I could absolutely attest to the fact that the less often that happens, and the easier and more intuitive it becomes to just simply know what has to be done, and want to do it and do it, just because it's the natural flow of things. It's, like, this is such a fine line, and I want to be very clear to the audience and everything. There's so much to discuss about cymatics, but I'm being very careful because of the platform. Okay. There's a lot of material here that I know about, that I know Nathan knows about, that we could really indulge in and make this a very, very robust cast. But I think that we have to do a lot of dancing, so maybe just understand that that's not for a lack of knowing. It's just that we have to be careful. But I'm gonna tiptoe and be easy on it, but just understand that cymatics has to do with material condensation and matter and how it comes to be. Okay. And when those forms come into be, it's also visible in our biological world through cell division and our embryonic development and things of that nature, just in every single facet of life, but also every single facet of how material crystallizes and comes to be. It's all visible and there, and it all is directly related to the resonant, like the inherent resonance of the material that it's being made out of, in conjunction with its resonance of its environment. Now, if you could imagine something that has a resonant frequency that is in tune with the environment in which it's being created within, okay, that is going to become its most perfect structure. Okay. But if you have something developing that's out of tune and out of sync with the environment in which it's developing in, one of two things could happen. You know, either it's going to develop in a state of dissonance and become imperfect, therefore, okay, or it's going to harmonize with and change its own vibration through sympathetic resonance, you know, to then match that of its interior, its exterior.
Okay, so let's bring this a little bit full circle.
Yeah.
We talk about resonance in water. We're made up of 70% water.
Yep.
So when you start looking at the puddle on the ground, just understand this. It's still going through you. It's still doing the same thing that you're seeing in the puddle. So as you're standing there at 70% water, don't think that that bag of water you're standing in isn't getting that same frequency put through it. So it's a good way to understand this. And we're building frequency patterns. And now if they build them in tune with the way that our body naturally operates, and if we say there's a pump going on with the Tesla coil, I still associate it with our heart. When you say blood is pumping through the veins, you're still getting energy inside your body in the same way. So now the frequencies start to make sense.
Yeah, it does. You know, Ben ran a test last night, and on the oscilloscope, he's like, and you know, this is this particular waveform. He's like, it's the exact waveform I'm looking for. It's just a little different than the last time I did it. That exact waveform that he was looking at was the exact waveform of a heartbeat under respiration. You know, so but what's unique is you got to remember, you know, in all the external factors, that's under respiration. You see, if you hold your breath either in or out, your heartbeat actually turns into a pure sine wave. You know, on a scope. You know, and again, we're not talking anything biological so much as we're talking about the electro, you know, physiology of that, I suppose. But you know, that's how that goes, and it's just interesting to see just that pattern repeating, because frankly, that's a distinct pattern.
So before we go any further, because it'll lead right to the subject we're not allowed to talk about, let's go back to the atom itself, and let's take a look at some of these patterns here. This is probably one of the clearest ones that we can see it, right? So if we had no electrons, this is what an atom would look like without an electron, right? So you see the inside of it, you're obviously getting magnetics on the inside. Now, the question is, this is obviously in 2D, which is a horrible representation, by the way, of anything that you want to look at when we're talking about an atom. Generally 3D is best, but this is 2D and we'll have to deal with it. The thing is, if it is fields, then it's telling you a story inside the field as it's rotating. So if I want to change something in an atom, I have to layer it one frequency over the next frequency in order to get the atom. And if I looked at the atomic weight of everything and I looked at the atomic structure of everything, if I turned them into patterns, then could I make them into fields? Then could I put them one over top of the other in order to combine certain elements? Certain elements will reject each other because the patterns are too far off. But if the patterns are somewhat, overlapping, when you put them together, they'll make harmonious resonance inside of that actual, piece of iron or that piece of aluminum or titanium or whatever you're trying to make. It'll actually run the frequency pattern correctly, versus if you put the wrong material together, it'll just crack up and break.
Yeah. I mean, what becomes interesting to me is, like, what if an atom itself, is realistically just analogous to a micro black hole, where, the event horizon is its shell, so to speak, and all of the stuff going on around it is stuff that, is pretty much being sucked into it, but not quite, in its own orbit, and whether you want to define that as a field or just, an energy pattern, and or something like that, and that would and then those outside orbits and so on give enough energy surrounding it to, push other, particles away and so on, so that the collapse of the center structure, I don't know, literally I'm just making this up as I go along. It's just an interesting thought, because I never proposed there are no atoms, but what are atoms? I mean, I've said that atoms are hyper dense energy, hyper dense energy.
Well, I believe there are atoms. I don't know that there's electrons. I know that there's fields because we can experience the fields. So what I'm looking at here, and the reason I brought up the metals, is quite simple.
Well, I'm sorry, just real quick before we go too far. I'm going to say, just, for my own 2 cents, I mean, I disagree with the fact that there's not electrons. I just think that what an electron is in sense has been somewhat misrepresented. I mean, I personally feel that an electron is a remainder of a deconstructive wave interference, where you have the top of a sine wave that's been clipped, and as the remainder, and then because it has inertial momentum, and it has bottom waveform cancellation, that it then has a spin as a result of, depending on its direction of propagation and the direction of the wave interference that caused the cancellation. So if that's what I think an electron is just a remnants of a stable remnants of a partially collapsed waveform.
Okay, then what would be the difference between the charge on an item and the electron then?
Which side of the line, whether it was a node or a whatever, what do they call it? Antinode?
Well, I'm asking, not so much that. We know that one side you could charge it positive, one side you can charge it negative. What I'm getting to is, if I replace the word electron and I put in a charge there, how much different is it?
Well,
the charge is basically a field that builds up in positive or negative, just like you said. So is there a difference then between the charge and the electron?
No, not a charge and an electron. A waveform and an electron, yes.
Well, we know that if we talk about a field and we talk about charges, you'd have to have them together, right? But does that mean that you could take out the electron at that point because you're replacing it with the charged state?
One more time on that, I'm sorry.
So we know that we have positive and negative on our charged state, and you can take them top to bottom in that way. Now, because we now know that we have that, could you now replace that electron of flow with the charged state?
I mean, yes, depending. The answer is yes, depending. And the depending is the difference between static and flow. And that has to do with propagation and matter and abundance. So if there's an abundance of electrons or charges, whatever you want to call it, there's an abundance of charges in the presence of matter with a source of propagation, which was, the result of it, then I believe so at that point. Because the jostling of those electrons or free electrons or whatever, however you want to define it, whether it's a created charge or whether it's a charge that's pulled through matter. You remember that these charges really only exist in the sense of matter, in the presence of matter. If you put them into nothingness, then they just resolve back to, a state of entropy, where they go back to a relaxed state.
Okay, so let's look at it a different way. If I took a Tesla coil and on the surface I said I had charges on the surface, they're naturally on there. As soon as I turned on the Tesla coil, I expanded the field that grows on the Tesla coil, but I also expanded the charge that was on the wire. Now I push that field out so it sits on the outside of that field in a charged state still. Now, most people would tell me right there, I would have an electron riding on top of the field. But is it the electron or the charged state?
Well, I mean, that's the difference between a plane and a field, though. When you have a propagation that's following some type of trajectory, so to speak, whether it be off the surface of a wire or however you want to put it, when there's a form of flow, as we'll call it, even though nothing's flowing through it, it's flowing and knocking one into the next. However you want to think about it, it doesn't matter. The fact is that there's a direction of propagation. That's the best way to put it, right? So you have this direction of propagation that runs on a plane. In fact, we know it runs on two planes, but the fact is that it's still planes. When the interactions between the planes then take place, that frees it up and expands it, and that's what creates a field of free electrons at that point to then polarize and do whatever they're going to do to create a field state, or if they don't reach any sort of polarization, and they could just be a cloud, so to speak, which is still a field, I suppose, of free static.
So I'm trying to make the point from the point of view that you said you believe in the electron. So I'm taking the point of view of the non-electron and trying to figure out how you would replace the electron and how it would be done, because a charged state can replace the electron, which makes it easier to understand field dynamics when you're looking for a dielectric. Then without the electron, the dielectric becomes very easy. It's basically one charge versus the other charge, and whichever one's bigger or smaller, we get a charge pushing to one direction. Now it makes it easy. But when I add the electron into that understanding of it, now you have to push electrons from one side to the other, which means you have loss. But in a state that we're in the dielectric, that loss isn't there.
Right.
So that's why I ask. And then we say, okay, we're going to build energy inside of a magnet core when we're running our I can't even think of the name right now. We're basically building the energy. So sorry, what's that? Generator. We're in a generator, we're building energy. Therefore, if I have electrons, every time that I build energy, I must build a new electron. So if I have to build new electrons, how many billions of electrons do I have to build to run the energy all the way to the other end, of 46 miles? That's what I'm getting at. But if it's a field and I'm just bouncing in between the field, then I don't have to build a single electron, but I get the same amount of energy.
See, but okay, so this is where my theory of it, and again, just a theory. This isn't hard, fast anything. This is just a way to think about it, if nothing else. If you, it's not even so much a matter. Okay, there's a difference between stable electrons, okay, that are part of matter, and solid material or liquid material, whatever, matter, okay, versus waveform made out of those particular electrons. So when you have a conductor and it has free electrons to be able to conduct a charge or a current, that it's that oscillation of those free electrons that are then creating a waveform, okay, out of electrons. So the electrons are of waveform in their initial state, but that's before matter was created. That's the mechanism in which they became atomically bonded to an atom, you know, at those stages, earlier stages. But now they're there, they're stable enough to be there, but not stable enough to not move and be able to trade because of the arrangement of the electrons within a conductor. So when you start jostling the electrons in the conductor, that creates the current. That current is represented by a waveform. It's those then propagating waveforms of electrons that are free and moving about the conductor, okay, that can then self-interfere with themselves because there's new waveform creation on a secondary basis. Now you have, for call it a virtual electron at that point, because it's not stable in the sense that it's bound to matter, but it's made by the same mechanism of its initial constituent. You
Right.
see?
What if I just said that the electron is a misunderstanding of the charge, though?
Well, it is.
If they
I
didn't
mean, it is a
understand how charge
misunderstanding of the charge.
worked, well,
I don't think an electron's a fucking ball.
no, I wouldn't think that you do. But
Yeah.
that's the way they represent it. Yeah. I think they made up math in order to find something that was already there. They just misunderstood it. And if I say that the magnet's connected in one way, but basically what I'm saying is I put a charge on the surface of those particular parts of the atom inside that magnet. And when it's moving, it then creates a field out of it. So when we say that the wire itself is the energy never runs through it. So if I had electrons, I would say that I just line them up one electron right after the other and say that they hit each one, and then all of a sudden at the very end you have the energy. But that's not how energy flows.
Yeah, and that's not how that works.
So energy flows on the outside of the wire, and you also have a magnetic field, and you have to have both. So you're going to have what would be seen as like a charged state, and you're going to have a magnetic state, and they have to work together in order to move that energy. So that's what I think is going on here, is we're having a misunderstanding because they want to put everything in an atom form. An atom may be completely different than just charged fields, or it could be the same thing as charged fields and how they're aligned. If they are aligned in the same way and they just have charges on them, then everything in nature is based on gravity, which gravity is simply a charged state that's pushing down because we're in between an anode and a cathode on a charged plate. Therefore, we're having force pushed upon us. I did an experiment like this, and all I did was take a piece of paper and made it look like a UFO, and I created a round disc at the top and a smaller one at the bottom, and every time that I did it, it lifted towards the big plate, and it didn't matter if the big plate was on the top or the bottom, it moved in one direction. There were no electrons on that. I simply built it based on the charged state that we see inside of that dielectric. And that exactly shows how gravity is working upon us. Because
that does, yeah.
Paper is not a conductor. It becomes a semiconductor when it's saturated, just like we do. We still have a conducting part to our body that we can move energy from it. And we do it in heat. We do it in electricity. When you go down the hallway in your socks, you still build up a charge. You still touch somebody and still zaps them. We still all laugh. But it's still the same thing. Gravity is not. I don't think there's any electrons. It makes it too difficult of an equation that you just didn't need. All you needed to do was properly understand the charge and the fields of those charges, and that the charge will ride along top the outside of the field instead of the electron on the outside of the field.
Right. I mean, you know, I guess it's depending on how you I don't disagree with that logic. But I mean, like, I kind of also feel like I kind of feel a different way about it. I don't know.
Oh,
Like,
go
how does
for
it
it.
like how does a capacitor work? Like, and I'm not saying, well, this is what a capacitor is, or is it? Forget that for a second. Let's talk about a capacitor. Okay, when you have a wire structure, okay, and you're running current through it, okay, that wire that is providing the electrons, okay, for the current to be in existence in the first place, okay, is coming into its own wave pattern interferences, okay. Its own wave pattern interferences are creating a surplus of not previously existing or bound electrons, okay. Those electrons are attracted in the vicinity of the initial electrons that were cause of its creation through its waveform interference. That accumulation and charge of electrons in that coil, in that circumstance, will resonate. The residual electrons will resonate with the sympathetic resonance that it achieved by virtue of its own creation with the coil that it's surrounding, and hold that charge until it's discharged. Well, what's that discharge? If there's no power source, how could it still hold that capacitance? Well, it holds that capacitance, the sympathetic resonance that created it in the first place. And what's coming out as the free charge from that capacitor is what was created as a result of that wave pattern interference through the material electrons, okay, that are free, but that are free to go. So you don't strip the free electron, the free valence electrons out of the conductor. You just take what they created as a result of their waveform interference by virtue of them being oscillated. Right? That's what a capacitor is. Like, so to say that, well, it doesn't exist or something like that, that's rough. Do I think that it exists the way that they tell you and the way that they explain it and the way that you're learning in your high school physics class? No, I think that's physics for dummies, just so you could get the most basic understanding of the fundamentals. But when you break down all of what's going on, and to the point where there's no more, well, why, that's what you're left with. You're left with a material that has, valence electrons that can move about its own internal crystalline structure that is capable of carrying a current and a charge. And then you have wave pattern interference by virtue of that current and oscillation that creates that free charge that could then be dispersed and used. That's the mechanism between a generator. That's the mechanism between a capacitor.
Okay, so let me ask you this. I'll show you something. And this right here is the way a DC wave moves in a pulse. So I take this right here, right? And all I have is a pencil here, and I have a little little thing surrounding it, right? So it runs on the outside like this. We're kind of on the outside. You see the field here. Now, every time I want to pulse it, I have to pinch it. What's that going to do? It's going to slow it down, and it's going to create heat in that one point.
Mm-hmm.
So if I want to do it again, I'll continue to do it. This is just how DC works. Okay, this is a pulse wave of DC. Energy's on the outside, it comes in and pinches. Capacitor is no different. A capacitor, the energy comes in, it's pinched, it's like a resistance. It doesn't let it go through, and it funnels it. Therefore, it builds up. Now we let it go, it goes back to full strength. That's all I'm doing in a capacitor, is I'm slowing it down. So if I look at it in this instance, I simply have capacitance in a different way. Now I don't need an electron. I can just use the field to create capacitance, because all I'm doing is pinching the field. Now, the whole key to this is I do not have loss in this system. If it's 100% system and there's no loss, okay, then the math will work out perfectly, because all I'm doing is creating less heat up here on this section.
Mhm.
I'm pinching the two fields together. I'm pinching my dielectric inside of my magnetic field right here. Therefore, that's going to create heat inside of any wire that's there. So if the pencil was the actual wire, then I'm creating heat in it. As soon as I allow that to go back to normal, to this state right here, now all that heat goes from heat as amps back into volts. Now I have more voltage here. If I take this reading right here, I have more amps here. Now I can take this simple thing and on how electricity moves in a DC on a wire, and I can put it directly into a capacitor, and I never had to use the word electron to do it.
Okay. Yeah, I mean, it's still not absent of waveform though, which is the
Well, that's the other thing. If I showed you this waveform, you'd show me a square wave that says PWM under it, right? Well, this is a visual representation of 360 degrees of a PWM. It is not a square wave. This is what the actual looks like. You're actually getting the bulge that comes out on the wire, because exactly what Steinmetz told you, that there's a magnetic field and then there's a dielectric field that goes on the wire. And this is how it runs. Now, when we pinch it, we get it like this. So this thing right here in no way is 2D, it's 3D. It actually solves the issue of what's going on here. We now understand it a little better, because in 2D, it doesn't make a whole lot of sense, does it? But now in 3D, it starts to make sense of why things are working that way. That's why it pisses me off when you see a physicist using algebra instead of geometry in order to understand this, because this is the way it actually propagates.
Well, algebra and geometry are, very closely linked with one another, but nonetheless, I understand exactly what you're saying. They're just looking at it mathematically as opposed to visually.
Well, the problem is every time they show a visual on it, they show it in 2D. So
they do.
If you show me a thing in 2D, I'm going to tell you you're full of it, because you do not understand how it works, and you can't see it. You're seeing something that's unrealistic versus something that's realistic that works. Now it's better understood. If you did this, you'd go, okay, well, now I can see the energy moving over the wire. I can see now where it pinches. I can now see why we're getting more of one thing in there, why the heat's creating the amp, and vice versa. And then how to bring it back out to literally more volts. That's as simple as it gets. And it also changes the frequency, how fast it's moving, because now I have less resistance in the pinch. Now my frequency goes up as my voltage goes up. My frequency goes down inside the pinch because my heat went up. Now we can start to see it the proper way. When we understand it, it all now makes sense.
Well, now he's starting to sound like Ken Wheeler, bro.
Well, because he's right.
He is right. I love Ken.
So the thing is when we look at this in an AC waveform now we have to look at it in a different way. If I took this and rotated it 360 degrees around the wire, now it would make sense why it's positive, negative, positive, negative, positive. Just as I rotated the actual thing around the wire, now we understand it, because DC is more of a straight voltage across. Mm-hmm. AC is now rotation. It's just a different understanding, but it's the same thing.
Right. It's a multi-plane propagation. But
if you're going to talk in fields instead of electrons, Ken Wheeler's the absolute best at it.
Well, I just think that electrons, in the sense of the importance in the stuff we talk about, is like less there, because realistically it's the secondary result of whatever field it is that it's creating, that ultimately is the usable the usable product of the electron. Like, realistically, the electrons themselves don't have, necessarily the most, I mean, I don't know. I don't know, Nathan.
No, hey, we're just
I don't see the
spitballing
benefit
here.
of eliminating them. I don't know.
I honestly think, man, we're just going back and forth on this. I like the field aspect of it. It's
I
going
like
to
the
create the same
conversation.
thing in the.
But I like.
But what I find funny is the field actually creates the same thing in the way the physicists say it. It just says no electrons. That's all. It's a whole different. We're not talking about electron propagation. We're now talking about a field propagation, which makes it a lot easier. And so either way they write it up, it should still end up to be in the same 3D structure. But in a lot of times you get physicists, they look at a 2D structure and then they misunderstand the reason why it's there. And it ruins a whole lot of experiments because now you're not understanding actually what's going on in it. Now you're making up stuff that's going on because you don't have a solid rule in place. You're thinking this little waveform, but as soon as I attach that waveform to a pipe and turn it sideways, your whole argument goes to crap. Your whole look at space-time goes to crap when you're talking about how you're going to go on here and you're going to make this thing sit on top of this flat piece right here, and then I'm going to change the bubble in the front and the bubble in the back, and I'm getting warp speed. That makes about zero fucking sense when it comes to geometry. It absolutely ruins
when it comes to geometry. Yeah.
Well, because it's not in the right dimension. It's in 2D. And it's like saying I'm creating warp drive on my tabletop instead of saying I'm creating it in space, which is 3-dimensional.
Yeah. No. I mean, I understand exactly what you're saying. I mean, at the end of the day, for visualizing it, it's much better the way that you're saying it and understanding it fully. It's definitely just oversimplified the way that it's generally portrayed and visualized by the academic community. I mean, I'll agree with you there. And at the end of the day, we're human beings with a finite amount of senses in, a realm and an existence full of things that we're trying to figure out, even in these discussions, that are beyond our, basic 5 senses. So sometimes we just try the best that we can to be able to, express these things in the most understandable way possible, I think. And, for academia, it tends to be just like, look at the math equation. That'll make you understand it more than this supporting photo or picture schematic, whatever,
Well, because they can't draw the right schematic to correctly illustrate something.
Well, right. You gotta have a very certain mind to only want to do math. And I'm pretty sure that degrades your capabilities on the other side of your brain. See episode 2 weeks ago.
Okay. Give me 1 second. I'm looking something up. So, man, where is it? I just had it the other day. Maybe it's in this one. Sorry, I'm looking up something that Sean did, and I wanted to show it because it was really relevant here. So, if I could just find it.
Probably should have logged into my computer before, but while you're doing that, I'm going to log into my computer too.
Okay.
There's a couple things I want to see. Follow along with the chat and stuff. There's a possibility that in doing this, though, that I might get knocked off. So if I do, I'll join right back up.
Okay. Oh, I think I found it. All right, hold on. Here we go. Yeah, I found it. Now we look at these. So based on what I just said about AC and how it flows around the wire. Now we look at these, and this is what comes out of the top of Sean's Tesla coil, right? There's a directional flow that if I put a wire right down the center of this thing, it simply moves in circles right down the whole thing.
That's awesome.
So if he says it's AC, and I want to look at this as it flows in a field around it, every one of these little tentacles, whatever you call them, tentacles, whatever, they flow right around as if there was a wire there, and they swirl right around it, just like I would imagine AC would around a solid wire.
I mean, it's very cool. I mean, I personally feel that Tesla coil of like, if you were like, you know, you could have one Tesla coil and that's the only one you get, I'd be going with one of these just because of how
cool it is.
How awesome they really truly are. And you know, can never say enough good things about Sean's work, you know, both aesthetically and functionally, you know, phenomenal. The field patterns that a spherical coil, you know, would implicate in the first place with the reduction of, you know, surface diameter of the coil as it proceeds toward, you know, the top apex of it. Like, you know, chef's kiss to that stuff, man. Like that's next level. Always is. Yeah, but just achieving the rotation, like you said, you know, being a good visualization of an AC waveform propagation through, you know, or upon a wire. Yeah, I mean, can you hit play? Can we see it, or is that just a screenshot?
Oh, it's just a screenshot.
It's a screenshot. Okay.
Yeah, I could look to see if I have the video, but
yeah, I mean, it's all good. You know, I won't take you away from it too much.
It was just
that, though.
Yeah, it was just interesting how he did it and that he made that. Hold on. I wanted to talk about this coil a little bit more because I did a test today and I was laughing the whole time with Joe as I'm doing this test, right? So we're over there talking about how the Tesla coil is kind of like a speaker where you have two magnetic fields, right? One goes and then the other one goes and it oscillates up and down. So I was trying to connect my Tesla coil to a flat metal plate. And basically what I was looking for in doing this is be able to create resonance on that plate so that I can actually get salt on it and then I can see a pattern. Did not work, okay? Absolutely did not work. As a matter of fact, all I did was burn my finger. So then we were having a fun time joking about it, and I said, well, let me put a condom on the top of this thing, right? So I go, all right. So what I did is I went and, like an old redneck way, and I went out and got some saran wrap, and I just simply put it over the top of the Tesla coil. And I didn't realize what was going to happen. Now, there was no wire hanging out or anything, and I put salt on it, and the salt did absolutely nothing, but it did make a couple cool sparks when I touched it with the electricity of the Tesla coil. But then something else happened. As I ran my Tesla coil, my energy output got better. And as soon as I put the light next to it, it actually pushed the energy further, but it also created more heat. So when I had my power supply connected to it, and my power supply is about 2.5 feet away, my Tesla coil, instead of turning on anywhere between 13 and 16 volts, I got it to turn on at 11 volts. And I'm just wondering, okay, the only thing that I'm doing is stopping the inside of this Tesla coil for breathing by putting the condom on the top. And basically what it did is it kept heat inside the coil. So the heat transferred into actual amps, and I was able to push the field further. Now, my actual power supply, it's aluminum, started to really heat up on me. And I just thought as soon as I did this experiment of Sean's Death Star coil, because of what Sean said to me, when he puts it in there, that you can feel the heat in the room rise. And now I'm looking at when it contacted something else, I can physically feel the heat on that item. That means that it's pushing out more energy. So in the stupidest way possible, I actually verified one of Sean's findings, and I now got this thing to push out a field further. Now, it's about, say, 8 to 12 inches longer, and I'm getting more heat out of it because I'm not enabling my Tesla coil to breathe. I don't allow the cold side to happen. So now I'm only propagating the hot side of it. Way cool of an experiment for simply putting a condom on top of your Tesla coil. And it looks hilarious.
Listen, we're going to have to do a thing on Rumble, dirty old man built. Yeah. It's funny
Oh my God.
I was joking around with my buddy Brandon. I forget who it was that recommended I pick this up. I feel like it was Sean, but I might be wrong about that. But I finally got my hands on a copy of called Ether Physics by William Lynn. Hard book to get, man. Like, I think there was like 2 for sale, and this one wasn't in the best shape. But like, you could tell, like, from looking at it, like, this was a book that was like sitting on some guy's like workshop bench, like on top of like 2 Playboy magazines and like 3 old cups of coffee.
Yeah.
For like years. Like, I could visualize exactly what its former life was. And this gentleman did me the favor of highlighting things that he thought would catch his eye and was interesting. And I was like, yeah, this guy probably should have read the book a couple more times and maybe tuned into our show or something. Because like, the stuff he highlighted, I'm like, man, this is the least important part of this book. Do you understand? Whatever. Doesn't matter. Neither here nor there. Just another thing to read. Yeah. So far, so good. Other than his ungodliness and his deeply conspiratorial thinking, which like I only partially resonate with, like on a case-to-case basis, it's sort of like, all right, Yeah. I believe in knowing all the conspiracies, but using your better judgment as to which ones to fully subscribe to. But in the world, one thing that I know is that we live in a very inconvenient world. So anytime you follow the little rabbit trails on something, and then you realize, man, this is all just way too convenient. Like, generally it's because it was dumb. That's sort of what it boils down to.
Wow, I didn't even read that quote. I guess I should have read it before I put it up. Oh wow. Anyway, I just find it very cool that we can actually start taking these things and testing out the theory and actually show the physical form of this stuff. So when he says he gets AC out of his Tesla coil and then I see it spiraling around, but then I look at how we're viewing energy, how it's supposed to go into AC form, then it's completely different. So that begs the question, is that wire on top of the line there to our houses actually AC? Because it does not feel like AC. What it feels like is a dielectric being pushed back and forth, or a dielectric that comes and pulls in energy from the ground in order to create the energy in the house. So if you're looking at 1,000,000 volts on the top of the line, and we know that the actual ground pulls in energy, and we saw that with Sean's Tesla coil, if I simply go over there and create some form of a pump, then the energy pulls from the ground. So it kind of begs the question. They say it's AC all the time, but then they always tell me a sine wave that comes out of your stereo is AC as well. And I'm still not buying that one. So it's just interesting to find out, guys, what's really going on here, and that we can see actual experiments that show this stuff so that we can get things corrected, so that we can only get in the correct mindset when we actually build this stuff. You have to envision it before you do it to know how it works together. sometimes I blindly put stuff together, just like I did today. But I still have to explain it. I still have to be able to say what's going on. And if you tell me it's dipole and I got to ram the dipole in this hole, and I just, honestly, the best thing you could tell me is about the field. Okay? Because not a lot of that other stuff is going to make a whole lot of, hoopla to me. It's just going to be another physics explanation of the field that I'm creating.
Yeah. I mean, at the end of the road of all the theory, too, is just the greater understanding of, how it all ties together. Because, like, at the end of the road, it's kind of, it's like a nice, like, bow on top of a car. That's really what it is. It's like that you realize that what makes this work makes that work. What created this created that, at just different scales of it all. That's what it all boils down to, And when you understand how things work, the problem with where we're operating in this dimensional reality of matter and energy and combination and flow is that it's very intram. It is neither one or the other. It's both. And because of this intram way that we go, we have to go one of either ways. We either have to harness energy or harness matter, and get them in some sort of equilibrium for it to work in this spectrum of reality. If you're entirely energy, it becomes a lot more simple. If you're entirely matter, it becomes a lot more simple.
But they have to work together.
That's the trick.
That's what I do. I believe in electrons and atoms? I might. That you can convince me there. Do I believe that they're on the fields everywhere? No, I don't. But do I think that you have to have some kind of electron in an atom in order to form a structure? Yeah. But I don't know how all that works out. I know they're not in movement. That whatever electron you're putting in there is not in movement. It stays in one place. So
yeah, I think this is a case of mouth sounds, though. Like when you tell the story and it's a totally different story, but it's the same exact friggin' story, but you sit there and you argue about which story is the way it happened. Like, I think that the meat and potatoes of it is all just the same, and depending on just how you want to describe it. I guess it's just mentally easier to picture little balls floating around and banging into like stupid crap and blah blah blah. It's just easier to imagine that than imagine a 4D live and active, abstract of a field, that is then being acted upon by upper dimensional mechanics to, consolidated in shapes that aren't even present in our existence. Like, yeah, you could get to that realm of thought, but without understanding the little floating balls, it's pretty hard to get there.
I don't think so. See, I think just the opposite. I think it's harder to get there with your balls floating than it is to, understand it in fields. Just, I completely see it the other way. And it's probably because I work on this stuff every day. So as soon as I turn it on, I know that there's a field there. Like, I can't imagine the little balls riding on it. You know what I mean? Like that little ball you used to ride as a kid with a little handle.
I don't like it when my balls are riding all over the place either, man. Floating and riding all over the place. I just like them to be, in a field of my underwear, well contained.
Wouldn't we all?
Yep.
I don't know.
The older you get, the harder it is. Well, depending.
Yeah.
See Alex.
Oh man, go get yourself 2 tubs and sit out in the middle of the wilderness then. See Alex. Yeah, if it was working, they'd be in the same tub. Oh man. Yeah, you know what? I think it's just totally really awesome to really see it this way, because I see it in fields, you see it in electrons.
No, I see it both, just to be clear.
Okay.
I do not disagree with you one bit, and it's not for our sake of playing devil's advocate. It's just the same thing, I think, you know?
Yeah. I think one of the bigger things that comes out of this is the actual patterns that are made from it that we're missing entirely by talking about electrons. That's what I think the loss here is, because we're over here dealing with little balls that go everywhere instead of looking at the pattern that's being created and the resonance that's underlining everything here. And that's a huge loss. It's why we don't understand everything. We're too busy arguing about balls in order to not see the resonance that's going on.
Yeah, but even when you look at the cymatic patterns, in fact, if you wanted to pull up any random cymatic pattern that I sent you, like that's got a few of them, what you will notice is like there's high points of condensate, like nodes that are perfectly spherical and round, you know, and that's a result of resonance, and it's a result of waveform resonant interference. That's all resonance really is anyway, is, you know, it's constructively interfering with itself and, you know, in tune with itself in a predictable fashion based on, you know, its environment, the frequency, and all the matter at play, and the medium. That's very important. Remember that cymatics isn't just necessarily an open air experiment or a vacuum experiment. You know, cymatics is created in, you know, water and oil and all of the different mediums, you know, result. Pardon me. You know, all the different mediums yield a different result, even with the same other elements, you know, the same membrane, the same matter that's being consolidated, unless if it's itself in that circumstance. So, I mean, yeah, I mean, it's a little hard to see in that particular waveform, although that's an amazing waveform. That's a 528 hertz waveform in water, which, you know, is directly analogous to a crown chakra and a pine cone. Yeah, but okay, so that's a good example of one. You see all those bright yellow spots? Those bright yellow spots are, you know, they're nodes. Those are high point interference. You know, that's a peak as opposed to a trough. So, I mean, however you want to think of an electron, or, you know, an energy peak or a remnants of condensate, or whatever, however you want to think about it, it's still part of the field.
But if the electron, the little ball itself, is just a field with the charge on the outside. But
well, that's exactly the situation at hand, of course.
But that's what I'm saying. It's a microcosm of what we just explained for the last hour and a half. It's the exact same thing. It's a field with the charge on the outside, which is the electron, which is bigger or smaller is the only thing we have to decide now. Are they little balls on there, or are they one big ball and you play with that? So it's interesting to see it in that way as well.
Yeah. And I mean, like I said, you don't have to know anything about this just to like look at it and think it's beautiful. And, you know, if you're one step above that, you could look at that and you see an egg formation in the middle, you know, of, you know, what appears to be, you know, cellular division.
Yeah.
You know, and that's at that second level of thought. And then, you know, you have your third level of thought, and now all of a sudden you're thinking about this as, you know, waveform patterns, you know, and it's contribution to internal formation of the waveform interferences. You know, it's all analogous. But if that doesn't look like an egg cluster to you in a pre-zygotic state, you know, of embryonic development, then I mean, I don't know. I guess you never saw the microscopic pictures of that. if you don't think it did, you know.
No, it actually looks right on. I think we're we're lost in some of the little details when it comes to this, and it ruins the bigger picture of everything, because there's certainly a pattern here.
Oh, yeah.
No matter how you want to look at it, there's a pattern.
Oh, yeah. This one's like one of the patterns. You know.
Yeah, let's see what else we got in here.
Notice something else about the middle. It's 3 and 6 pointed.
It's the seed.
Yeah.
It's the seed of life.
Yep.
It's exactly what it is.
Seed of life, like an egg.
Yeah.
Yeah, I know. That's wild stuff, man.
It all definitely ties in together when you're building this stuff. And when I describe how the coil is built, and then what you're getting out of it, it ties right back into it as well. And you'll start to understand why the Russell scale is the inside of the vortex, and you get to really understand what you're dealing with here. It's all coming out to be known of what everything is in this stuff. But the thing is we actually found the way to make it work. Well, I didn't anyway. Gerald did. I didn't. But that's it. That's the whole key to the whole thing of everything in coil building. Why do you do it? Well, because you get stuff that you understand like this that comes out of it. And it all had to do with magnetic fields and how they work, and how to make a bigger magnetic field out of something so that you can control the temperature of the room. That's the cool next part of it is when we get past understanding this, we're going to start moving into, now that we understand how it's built and how it looks and how the vortexes come out of it, now we need to understand how it changes temperature in the room. As soon as you get past temperature in the room, we get into time dilation.
Yeah.
That's what's cool. So
that is cool.
It's the real understanding of how you move the heat and cold around in your system, how you can get time dilation, how you can get vortexes to operate, and then how do you switch them between north and south? Which way does the pump run? Things like that. And then you can't forget that it's going through the entire coil, and then the next one is going through the entire coil, then the next one. So you're literally having two fields like this, but they're like this. One goes up while the other one goes back down in energy. One goes up while the other one goes back down in energy. So you get a pump like this, but what it's doing is it's pumping one side than the other, right? So, and it's slightly off tune, so it'll go like this. That's what's so amazing about this. And then
it really is, yeah.
Now you get to see why things are built, because you're building them with energy in them already. That's why the G-shell is created like a 3D printer.
There's some stuff in the chat going on that I think probably worth talking about.
Okay, what is it?
So there's this whole the seed and flower and 4, 6, and 12. So I realize the relationship between 4, 6, and 12. 4 being a square and 6 being a cube. And then also tie that into what I had said previously about the significance of the imperial measurement system and the fact that it uses a 3, 6, 12 basis, but then that's also broken up into halves, quarters, eighths, and sixteenths. See, all this stuff these are all little keys, fractions of significant numbers and geometries, okay, that can be broken down in a way that's more consistent with the natural patterns as opposed to a decimal 10 system. Okay, and that's really what it boils down to. So your seed of whatever it is, the seed of 4 turns into the flower of 6 is the same analogously geometrically as the square turning to the cube, and so on. It's no accident why there's 12. We have a 12-hour clock that goes around twice, and that the 60 minutes are broken down into the 12. None of this stuff is accidental, and it's all geometric. And the geometries that are described in the imperial through use of imperial measurement systems are directly analogous to a lot of the patterns that are found in the sacred geometries, which are direct representations of the the fields of energy that are produced as a result of all the mechanisms you're describing, whether it be the pumping actions or just the general propagation of the waveforms and fields. So
now we know why Gerald's
realize
head was
together.
exploding as soon as Victor told him what he knew. Because as soon as he started bringing the fractions into it, the fractals in it, then Gerald understood it perfectly because of the geometry he was using in the shapes to build that coil.
Yeah, it boils down to, the spiral maths of it, which again directly ties into phi and the golden ratio. It also directly ties into, the vortex maths, I should say, because not every math system needs to be broken up into group of 10. You could use repeating fractional different ratios. It boils down to ratios of fractions. They could be decimals too, but they're more properly and wholly represented by a fraction as opposed to a decimal.
Yeah. Well, they definitely knew what they were doing, the right way to go. I'm just glad we didn't change our system and then get completely lost. It's bad enough they changed the frequencies on us. So we have to go back to that now. And now if they start changing to a decimal system instead, we're going to be all lost. It just won't make the same sense.
No, it won't. And I love it. And I've seen videos and stuff, with like Europeans and stuff being like, stupid Americans, in their imperial system, it can't be like the rest of the world. Like, well, yeah, I have 4-letter words for you, guy. Is America 4 words? Merica? No. That's that.
Oh, the Fibonacci spiral. Absolutely.
Yeah. And you got to remember the Fibonacci spiral is the feminine of no, I'm sorry. It's the other way. So yeah, Fibonacci spiral is the feminine of the golden ratio. So what happens in the Fibonacci spiral is that it starts off close but no cigar to it, but gets ever so closer to it, and then pulls away from golden ratio, but then gets ever so closer to it in that same exact repeating pattern. The further on that it goes, the larger the numbers input, the closer it gets to golden ratio, whereas golden ratio is just simply golden ratio. But the difference is that's a square pattern. It's a square waveform, golden ratio, as opposed to Fibonacci, which is a circular. Then that's the difference between the two. Now, a lot of people use them analogously, but they're not exactly the same. They just follow the same general pattern. But
well, it makes sense if you look at the top and bottom of the Earth, one pushes out, one takes it in. That's the way it works.
And DC is analogous to the masculine energy of a square wave, whereas Fibonacci follows the feminine of a sine wave.
Interesting.
Yeah.
Man, everybody in that chat sure does have fun on these shows. I can tell you that.
I love that.
Yeah.
I wish I could create like a second one of myself to be in the live chat at the same time.
That's so great.
Yeah. Maybe if you ever get that time dilation thing figured out, I could both be here and there at the same time. Who knows?
Well, yeah, because there's things that I would say in the chat I'm not allowed to say on air. So
I take full advantage of that frequently.
Oh, write a book, guys. Yeah. Well, we're just gonna go ahead and put it on any platform that'll allow us to talk about it. Because I guess the hardest thing is since I see it in my head, it's hard to translate when you're not able to say two parts of it. You know what I mean? If I'm not allowed to bring up medical and I'm not allowed to bring up religion, well, then guess what? You're going to miss a whole lot of it. And it's like a pattern that's missing parts again. And it really sucks, to be very honest with you.
Mm-hmm.
Because if you saw the whole pattern like I see it or Joe sees it, and then you just like, you know, that moment where, you know, the sun's shining at your back and everything. And it's like, now I get it. Now it makes a lot more sense. But it's truly unfortunate they won't let us communicate in that way.
Yeah. I mean, unfortunately, you get like the half of me, you know, and it's like this conscious half of me that's like half watching what I'm saying at all times and neutering every pure form that wants to come out of my mouth just because I'm a dirty son of a bitch half the time. Like, it just is what it is. But that's me, you know. And I know then there's all the topics that we have to dance around, and that neuters it too. And you know what? It's good that if people are still enjoying it and stuff, and you know, there's 30, 40 people on your platform watching this live per week. More power to you people. I love you for it. You know, but it's like this would be so much more. I think like entertaining and just like natural flow for me, at least, you know, if we were just able to get out with it, whatever it was. That's it, plain and simple, you know?
Yeah, because it makes a whole heck of a lot more sense. It really ties it together in a way that, like, everything on the earth is created this way, and you find out why, and then you'd be like, oh, well, why in the world were we not taught this? So,
yeah, because the world's filled with a bunch of fucking idiots, Nathan. Pardon my French. We're pretty deep into this cast, though, so it'll be fine.
Yeah, what I was gonna do was just put it all in one format and just simply blank out the sections where it says YouTube will not allow us to discuss this. But then, as soon as you get to the next chapter of it, you have to go back to the chapter that was censored. You know what I mean? And you keep repeating because it all interties, and then it makes it almost impossible to do the video.
Yeah, and especially on a topic like this, you know, there's so many routes that it could go with, you know, things we can't talk about. You know, just bring the it's like something inadmissible in court where, like, you know, you're going to get an objection if you say it in front of a jury. But guess what? You ring the bell, right? So anytime we say, "Oh, we can't talk about it," people, you know exactly what we're talking about, and if you don't know exactly specifically what it is, just, you know, do your own little independent due diligence and, you know, catch those little ringing of the bells. You know, that's it. So all we could do at this point, you know, until, I mean, I checked Rumble out for what it's worth, you know, and it's like actually seemingly a pretty good platform, like, but it just simply doesn't have the amount of people on there to reach a significant audience. And that's what it boils down to.
I agree.
You know, if it had the audience, then there'd be no sense in doing this on YouTube at all.
Yeah, well, they're going to let us tell us what it actually is, yeah. And, you know, I don't know. I don't want to sit there and write a creepy book about what everything is. You know what I mean? It'll sit on the shelf and collect dust. I'd rather just say it and be done with it, and then let the experiments speak for themselves, because they absolutely prove it.
You know, and I've brought this book up 1,000 times and probably 1,000 more, but Bentov wrote a book, you know, the Swinging Pendulum book. And he starts that book off by saying that this book is a result of the culmination of many, many, many discussions had between me and friends over alcoholic beverages in my living room.
Nice.
You know, like he's like, this is, you know, he's like, we would have these conversations, and, you know, after enough of them, we said, you know what, we ought to be coming up with some kind of consolidated coherency to this, and then restructure that into a book. And that's exactly what they did. And it's wonderful because it's both entertaining and layman and human and explanatory and profoundly deep all simultaneously. Like, he nailed it. Guy was a genius, you know.
Nice.
And then the government got him. You know, they hired him at first and then they got him.
Oh, wow.
Ain't that the way the cookie crumbles?
Yeah, always is.
Yep.
All right. All right, Joe, we're at 2 hours, man. I think it's time to call it a day here.
Yes, sir.
So I want to thank everybody in the chat for showing up today, hanging out, and giving your opinion out there. Guys, it's been awesome.
Peace and love.
I'll see you guys tomorrow, and we'll do open mic, see what's going on. Hopefully, what I want to do is look at a couple of the YouTube channels out there of the smaller inventors or smaller channels as of right now that are out there, and we can take a look. I know there's like 4 of them I've been checking up on regularly, so I'd like to feature those tomorrow.
All right, man. Sounds good. I'll be looking forward to it. Thank you, everybody in the chat. You know I love you all, and probably catch you next week, and maybe you never know. I'll pop in during the week and bother and destroy somebody's cast. Probably Ben's.
Right on.
All right.
Thanks,
Catch you
guys.
later.